Our topic is normal distribution. As in the previous topic, we had the discrete distribution. We made the probability in a table. Here, because the variable is not is continuous, we cannot make table, and we have to make a graph. Our graph would be the normal distribution graph, which looks like this. This is the normal distribution graph. The normal distribution graph has this shape. It is low values has low probability, high values low probability, and of course the majority in the middle. A normal distribution, this line is in actual fact represent the mean and also represent the median and also represent the mode. This, right, in the normal distribution, we are going to calculate probability that the value is less than a certain number. And just like in the histogram, when we ask you to get how many before that value, you calculate the area to the left. We have exactly the same thing here. What is the probability that it is below this value? It will be all this area, all that area. Therefore, the probability values, we are going to get them from the graph. From one problem to other problem, the differences between a problem and another is the mean value will be different and the standard deviation will be different. Here we are going to use at the start something we call the standard normal distribution. The standard normal distribution. The standard normal distribution graph, we call it Z. This is abbreviation. Z is a normal distribution with the mean value 0 and the standard deviation is 1, therefore the variance is 1 squared. This value is 0. This is the mean value. This means that is normal distribution. This is the mean and this is the variance or standard deviation squared. This table, there is a table provided which will give us the values of the probabilities. For example, if I want to find the probability that Z is less than 1, then this value is 1, and we have to find this area. This we get from the table. This is a table. This table gives us the values of Z and the probability. Z equal 1. But the area up to 1 is 0.8413. The answer is 0.8413. And as we know that the total probability is 1, means the total area under the graph is 1. Therefore, if I ask you what is the probability that Z is greater than 1, it will be 1 minus. We call this value phi z. We call it phi z. The values here in the table are called phi z. Right. Now you have a 1 minus phi, right, 1. Therefore, which is equal to 1 minus 0.8413. And we get the answer. Therefore, we say this. The probability that z is less than a value z is phi z. And the probability that z is greater than a value z is 1 minus phi z. This is how we calculate values. Now, if we have a value of z, this table, it starts at the value of 0.5. It starts at the value 0, and its probability is 0.5. 0 is the least value. There are no negative values of z in this table. Therefore, how do we get the probability for a negative z? Therefore, we say this. This is a probability distribution, and we want to find what is the probability for a value z, negative value. Right. Now, let us say this is a negative z, right, minus z. To get this area, it is identical to this area. Exactly. Therefore, phi negative z is exactly equal to 1 minus phi z, because this is z and the area before z is phi z. Therefore, this area 1 minus this, and therefore we have a rule: phi minus z is 1 minus phi z. Now, if we be asked to find what is the value between two values, for example, this is a normal distribution, and I ask you, this is a value A and this is B. What is the probability that Z is greater than A, less than B? We find phi B minus phi A. The student should have some practice on using this table. Sometimes we are going to be given that we will be given the probability and want to find the value of Z. Then we look at the values of phi Z and we read back the values of Z. If phi Z is less than 0.5, that means Z is negative. If I set you the probability, right, that Z less than a number, which we call phi Z, and I gave you the answer is less than 0.5, that means then that Z is negative. Right. If I set you the probability that Z is greater than the number A, and the answer greater than when the area is the one more than 0.5, this means again the value of A is negative. Now, how do we calculate, how do we convert a normal problem into a standard problem? Right, and now we know that we can transform any normal distribution into Z. How this is done? This is done this way. Now we have a variable x and a variable z. The x-axis here, and this is a normal distribution graph. Here z is 0, and here x is mu. Mu means the mean value. This is the mean value. How do we calculate a problem, a general problem, into a standard problem? By this conversion, z equal x minus mu over sigma. For example, the following examples will illustrate the idea, right, of this normal distribution. For example, if we have x is a normal distribution with the mean value 50 and 4 square, it means that the variance is 16 or the standard deviation is 4. If we were asked to find the probability that x less than 53, what are we going to do is we are going to convert x into z. We say the probability that z is less than 53 minus 50 over 4. This is the probability that z less than 0.75. 0.75. We go to the tables, the normal distribution table, and we look at 0.75. 0.75, and probability is 0.7734. 0.7734. And this is the answer to the question. If we were asked to answer this question, what is the probability that x less than or equal, does it make difference, less than or less than and equal? In the normal distribution, no difference. 45. This means the probability that z is less than 45 minus 50 over 4. This is the probability that z is less than negative 1.25. This means phi negative 1.25, and phi negative means 1 minus phi positive 1.25. This means 1 minus, and we look at 1.25, the answer 0.8944, 0.8944, and we get the answer by subtracting this minus this, and we got 1054. 0.56, and this is the probability. Let us have another example. Now, on this example, let us extend the problem. Right, like what? If it sets you the other way around, what is the value given that probability that x is greater than a number a, right, and the answer is 0.2. Now, what is the meaning of this? This is the meaning that we have a table. This is a graph. I mean, this is the normal distribution, and the number a is here, and this area is 0.2. When you are given the area to the right and the answer is a round number, not 4 decimal, then the table at the back of this table, we have another table. This table at the back gives the values to the right, and if the area to the right is round number as listed here, 0.5, 0.4, 0.3, 0.2, 0.15, 0.10, and so on, 0.05, when these values like this, then we can use this table at the back to get the answer, because if we wanted to get the answer from the other table, then we have to search for 0.8. We have to search for the values of phi z 0.8. We will not get phi z 0.8. We will have phi z here. Now its value is 0.7995 and 0.8023. These correspond to 0.84 and 0.85. But the table at the back, which is at the back of this table, we have this table. We look at 0.2. 0.2 here correspond to 0.8416. That means the value of z is 0.84, right, 8416. And I know that z equal to x, which is a, minus mu 50 over 4. And doing the calculation, we'll get a minus 50 equal 4 times 0.8416. Right, if we calculate 0.8416 times 4, we get 3.366. This means the value of A is 53.366, and this is the answer to the question. Let us have another example. Now, if we have a problem, right, like Let us have a problem, right, a good problem from the exercise like this. Now, there's a question here. It says the following, right? X is a normal distribution, 35 square, 35 square, right? I'll find the value of A, right, given probability that X is greater than A is 0.3. We must understand this in the graph here. The area greater than means to the right of the line. The area to the right is 0.3, right? Therefore, this area there is 0.3. Accordingly, we are going to look at the table at the back, right, and we see the number 0.3. The probability for 0.3, 0.5244. Z equal 0.5244. The same as we did before. We're going to say A minus 30 over 5 equal 0.5244. And we calculate the value of A equal 30 plus, and we multiply these two numbers and get the answer. But if we have a problem like this, right, if the same question here were given a probability that X greater than a number B, okay, right, and the area, the answer was given that the area greater than the number B is, right, 0.8849, 0.8849. Let us understand this. The area to the right of the number B is greater than 0.5. This means B is here. This means the value of Z, right, corresponding to B is negative, because this area is 0.8849. Now, we know that there is an equivalent to this graph, an equivalent value there, which this area, right, for symmetry, if this area corresponds to this area, but this Z here equals that Z there, but this is positive and this is negative. And therefore, we look for this area, this area to the left of the line, and therefore we look at the table in the front. The table in the front gives us the value 0.8849 is 1.2. Therefore this Z here, Z there is 1.2. But what is the value of Z there? But Z there is negative 1.2. This means B minus 30, over 5 is negative 1.2. This means b minus 30 is negative 6. Therefore, the value of b is 24. Therefore, drawing the probability distribution makes you understand the question, make you understand what should you do. Now, if we got the area right, if in the same problem we were given another question again, given probability that x less than c, right, equal to okay 0.4. 0.4 is less than 0.5. This means 0.4 less than 0.5. This means that c is negative. Therefore, again, we say there, this line is 0.5. The area to the left of the line is 0.4. This is 0.4. Therefore, we find the corresponding line here where this area 0.4. We get the value of z here. This time we're going to look at the table, at the back table. And in the back table, 0.4 corresponds to 0.2533. This is z here, but this z is negative, therefore z is negative 0.2, right, 533. And therefore we're going to say c minus 30 over 5 equal negative 0.2533, and then we calculate the value of c. This is how you can solve problems, right? That you are going to be given a general problem and you convert it into a standard problem, making use of the both tables, the table, the main table, and the table at the back. Let us have another type of problem. Now, we can have problems in which mu and sigma sometimes missing. For example, we can have this problem. We can have a question saying this, right? It says that x is a normal distribution, right? Mu and 3 square, mu 3 square. And we are given that the probability of x greater than, that x greater than 20 is 0.2. Now, greater than and less than 0.5, that means the value z is positive because this is z and this area is 0.2. If that area is 0.2, we look at the table at the back and we find the value corresponding to 0.2, 0.8416. You have a z equal 0.8416. Therefore we say x minus mu. X is, right, 20. 20, okay, minus mu over 3 equal 0.8416. And we find the value of mu, and we'll get the value of mu 17.475. 17.475. Another question. We are given a variable x, that it is a normal distribution, 50 sigma square, and we are given that probability that x less than 46 is, the area is 0.2119. Now this area to the left of the line is less than 0.5. That means that is negative. Therefore this is a line here, and this area 0.2119. We have an equivalent area here on this side, again 0.2119. So what is the area to the left of the line? We subtract 1 minus 0.2119. When we subtract 1 minus this, we get 0.7881. We are going to look at the table, the main table, and we'll search for phi z equal this number, 0.78. We get the number 0.7881 is 0.8. That corresponds to z equal 0.8. So our z here is going to be negative. Therefore our z is negative 0.8. Therefore 46 minus 50 over sigma is negative 0.8. 46 minus 50 is negative 4 over sigma is negative 0.8. Therefore we can find the value of sigma equal to, right, so we calculate the value of sigma, and sigma equal to 5. Sometimes we have both values of mu and sigma are missing. For this example here, it is given that x is a normal distribution, mu sigma square, and we are given that probability that x greater than 35 equal 0.05, and we are given that the probability that x less than 15 is 0.1469. Now this is the area to the right. Right. Therefore for the first case we say this is 35, this area is 0.05. Therefore we look at the table at the back. The table at the back, 0.05 is 1.6449. If z is 1, right, 0.6449. This means that 35, right, 35 minus mu over sigma equal 1.6449. Then we are going to do the other one. Less than 15 is less than 0.5, means 15 is to the left of the middle line. 15 is here. And this area is right, given the value here, 0.1469. There's an equivalent area here. Therefore, we are going to get the area before the line, so 1 minus 0.1469. 1 minus this number, right, it will be 1 minus the value 1 minus 1.4, we get 0.8531. 0.8531. We look at the table and we see that number 0.8531, 0.8531, right, is 1.05. If Z is 1.05. So we get another equation, 15, 1 is going to be negative. 15 minus mu over sigma equal negative 1.05. Solving these two equations simultaneously, you will get the values of mu and sigma. How to solve them? We make cross multiplication, right, in order to solve these two equations. We are going to do it here. The first equation we have is this, right? Now, first equation is 35, right? Now, minus mu equal 35 minus mu equal to 1.6449 sigma. And the second equation is 15 minus mu equal negative 1.05 sigma. Right. These two equations, right, when we solve them, it says here x greater than 30.05. 0.05 at the back table yes, x greater than 35 is 0.05. 0.05 the area 0.05 is right, and the area 0.05 is this, yes. We solve them. How do you solve them? We subtract the two equations from each other. 35 minus 15 is 20. Cancel. This minus this. Right, so we need to add 1.6449 plus 1.05, and we get this is 2.6949 sigma. We get the value of sigma, 20 over this number, 20 over that answer. We get sigma equals 0.42. And then we substitute in the first equation, or in the second equation would be easier. If mu equal 15 plus 1.05 times 7.42, right, times 1.05, and we get to add this plus 15, and we get the value of mu equal 22.79. This is how did we solve the problem to get the values of sigma and mu. We are going to have this kind of questions, but it will be written in the context, not and say in symbol, ولكن in words, right? Yani we have this exactly the same problem, saying here, for example, that the heights of large group of women are normally distributed with a mean 165 and a standard deviation of 3.5. It's saying the question. Therefore, we know from there we read, we get mu is 165 and sigma equal to 3.5. Then say, what is the probability that a woman will be shorter than 160? What is the probability that x less than 160? We are going to convert to the z, therefore probability that z is less than 160 minus 165 over 3.5. From this, right, we get a probability that z less than, right, negative 1.4285. Means phi but negative. Phi negative means 1 minus phi 1.4285. Therefore, we go and find 1 minus, and we look at the table and we search for 1.4285. The nearest is 1.43, and we look at the value 1.43. 1.43, we get 0.9236. 0.9236, and we find the difference, we get 0.0, right, 764. Now, Stephen is looking for a woman whose height is between 168 and 174. For a part, find the woman who have me a woman between two values. We want the probability that x is greater than, right, 168, less than 174. Therefore, we get the probability that z is greater than 168 minus 165 over 3.5 less than 174 minus 165 over 3.5. Therefore, we get the probability that z is greater than 0.86 and less than, right, 2.55. So we get phi 2.55 from the table minus phi 0.86, and then we get the answer, and that difference will be 0.18 0.95. And this is the topic of normal distribution.